In this video, we'll be talking about radians, a unit of angle measure. Let's begin by reviewing a couple of key concepts regarding circles. First of all, a circle has a shape, and that shape is the set of points equidistant, that means equally distant, from the center point. So hopefully at some point in your math career, you've had the opportunity to actually draw a circle with a compass. Now, if we draw a line through the center point that hits the edges of the circle, that entire line is called the diameter. For hundreds and actually thousands of years, people were really interested in what makes a circle, and then what is the relationship between the circumference and diameter of a circle. So again, the diameter is the measurement across the widest point. It goes through the center. And the circumference is the distance around the circle. And of course, we know that the relationship between those two numbers is a special number called pi. So the Greek letter pi is equal to the circumference of a circle divided by its diameter. We can rearrange that formula to say that the circumference of a circle is equal to pi times the diameter. And we can also say that since the radius is the distance from the center, I'll use a different color. It's the distance just from the center out to the edge, and the radius is half the diameter, then we also know that the circumference is equal to pi times twice the radius, otherwise known as 2 pi r. Okay, so that's our first thing that we want to know. Now, we also want to make a relationship, an explicit relationship between rotating a circle and that circumference. So I'm going to show you an animation here. So here is an animation of a circle. It says that the circle shown below could represent a tire. And I just want you to look at how the circumference could roll out to create a linear distance. That's something that we're going to be looking at in our physics class. How, again, the circumference could roll out to create a linear distance. That's something that we want to think about. Okay, so back to my pictures here. So we know that if I were to start on the coordinate plane, oops, let me try that. Let me just start this over again. Okay, so let's put a circle on the coordinate plane, at the center at the origin. Let's see how close I can get here. That looks pretty good. We know that once around the circle is the circumference of the circle. And if I wanted to actually walk this distance, so if this were me, and I were walking all the way around the circle to get that circumference, the way that I could calculate how long that distance is going to be is I could use 2 times pi times r. Now, what if I were just going to walk to this point right here? That point is 1/4 of the way around the circle. So if the whole way around is 2 pi r, if I divide by 4, I would get that 1/4 of the way around the circle is pi over 2 times r. Okay, what if I were to go to the next point, halfway around the circle? So we'll call this 0.1, and now we'll do 0.2. So we've got 2 pi r over 2. Now we're dividing the circle in half. That would be just pi r. So it turns out that this part of the formula, the pi over 2 and the pi, are very useful, and we can use those not just as a way to calculate distances, but we can also use them as angle measurements. So if I just look at the pi over 2, what if I called this angle measurement pi over 2? You might be used to calling it 90 degrees, but we can also call it, if we use a different unit of measure, we can also call it pi over 2. And in fact, pi over 2 is a unit of angle measure called the radian. We're going to be using radians a lot in this section. Let's go to another animation to take a look at this more. Okay, here's a radians illustration. So I'm going to show a radius. I'll maximize this. Let's see if it'll go. There's a radius. Okay, now I'm going to take this radius and I'm going to slide it over and wrap it onto the circle. Now, how many times do you think I could do this? Okay, so first of all, this central angle that I just created by laying one radius along the circumference is 1 radian. I'll show a second radius. I'm going to take that second radius and wrap it around the circle. And now that is 2 radians. I'll do it again. Slide it and wrap it. That's 3 radians. Okay, we're getting the hang of it now. Oops. And what you should expect here is that I'm getting 6 pi or 6.28, I'm sorry, 2 pi or 6.28 radii fitting around this. So that's 6 radians, and this little bit that is left is, that little bit that is left is 0.28. Okay, so let me restart this. I'm going to take this and put this in my notability. Okay, thank you for your patience. Okay, so let's formalize our knowledge a little bit here. Here we've got this situation where we took a radius, we wrapped it around the circumference, and when we have a portion of a circumference, the name for that is an arc length. So, oh, that's not letting me write on there. There we go. So that distance there is called an arc length. This is a central angle measured in radians. And then, of course, we have the radius. And it turns out that there's a relationship between these 3 things. The arc length will equal the central angle times the radius. And if I write this symbolically, arc length is going to be an S, central angle is going to be a delta theta because we're sweeping out a portion of the, or we're sweeping out a central angle, and then the radius is just going to be r. So hopefully this makes sense that 1 radian is actually 1 radian of angle measure per radius. So let's look at an example here. Let's suppose that I've got a circle and the radius of the circle is 4 and the angle, the central angle, is pi over 2. Pi over 2 is equal to 90 degrees. Remember from my picture before that 180 degrees would be halfway around the circle. That would be equal to pi, and 360 degrees, pi radians, pardon me, and 360 degrees all the way around the circle would be equal to 2 pi radians. So if I wanted to find this arc length, it would be equal to pi over 2 times 4, or it would be equal to 2 pi. If the radius was in meters, my answer would be in meters. If you didn't know about radians, you could figure it out using maybe what you learned in an earlier geometry class. Circumference is 2 pi r, so the entire circumference of the circle would be 2 times pi times 4, which would be 8 pi. But we've only got a quarter of the circle here, a quarter of the circumference. So if I take 8 pi, divided by 4, I get 2 pi as that arc length. All right, that's your background information on radians.